Okay, this is lesson 3.3, equations in y equals mx form. If you are not on page 90, please pause the video and get to that page now. Okay, so let's take a look at example number 1, which is right here. So it says the amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. So this is asking, how much money does Robin earn per hour? For 1 hour, how much money does she make? So one way to do this is to come over to the graph and find where 1 hour is in 1 hour and then follow it up to where the line crosses, because this is how much she earns. So in 1 hour, she earns between $5 and $10, because this would be 5 here if this is 10. But we don't know exactly how much she earns per hour by looking at this line. So what we're going to do is we're going to find points on this line and find basically the unit rate or the constant of variation. So you can use this ordered pair right here. So in 2 hours she makes, if you look across here, in 2 hours she makes, this would be $15. So she makes $15 in 2 hours, so we would find the unit rate and divide. So let's do that. 2 into 15 goes 7 times. Subtract, and I'm going to add a decimal and bring down to 0, and then 2 divides into 10 5 times. So to make this money, 7.5 would be $7.50. So we can use that point, or we can use this point right here and divide and get the exact same thing. So in 4 hours, she makes $30. So she makes $30 in 4 hours. So let's divide and see if we get the same thing. So 4 divides into 30 7 times for 28. Subtract, we have to add a decimal and bring down to 0, and 4 divides into 25 times. Again, to make this money, we're going to add a 0 at the end. So final answer is that no matter which point we use and divide, we're going to figure out that she makes $7.50 per hour for each hour she babysits. Okay, let's take a look at the got it problem at the very bottom. So you're going to do this in your book with me. So it says 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. So there's a key word there, descended 1,900 feet. After 5 minutes, he descends 4,750 feet. If the distance varies directly with the time, so it's telling you it's a direct variation, at what rate is the skydiver moving? So because it's telling you that distance varies directly with time, distance varies directly with time. So we're going to put distance on top, time on the bottom. So let's take this first one. Distance, descended 1,900 feet. Now, if you were to draw this graph, it would be up here, and descending would mean going down. So that's a negative 1,900, divided by the time. So he descends 1,900 feet in 2 minutes. So now let's divide. 2 into 1,900. 2 divides into 19 9 times for 18. Subtract, bring down. 2 divides into 10 5 times. And then you have this one last 0 that you're going to put up. And because the distance is negative, so he descends negative 950 feet per hour. This is exactly how you would label your final answer. Negative 1,950 feet per hour. You will also get the exact same answer if you divided 4,750 feet by 5 minutes. Remember, you can use any point that lands on your line. So let's do that right over here. Negative descending 4,750 feet in 5 minutes. So you're going to divide 5 into 4,750. 5 goes into 47 9 times. Subtract, bring down. 5 goes into 25 5 times, and then you have to bring that last 0 up. And again, negative 950, oops, feet per minute. Oh, you know what? I think I labeled this one wrong. This is negative 950 feet per minute. It's not hours, it's per minute. Okay, so either way, either information, either point that we use on the line will give us the exact same direct variation. Okay, let's take a look at one last problem. We're at the top of page 191. So a cyclist can ride 3 miles in a quarter of an hour. Assume that the distance biked in miles, y, varies directly with the time in x hours. This situation can be represented by y equals 12x. Graph the equation. How far can the cyclist ride per hour? Okay, so basically this y equals 12x, this is your slope. This is telling you how many miles he can bike per hour. This number right here. So if you take a look at this, this is saying 3 miles in a quarter of an hour. Well, there's 4 quarters in 1 hour, and each one of these he bikes 3 miles. So you can add these up, 3, 6, 9, 12 miles, or 3 miles times 4 quarters of an hour. You will still get 12 miles per hour. So what you would do is draw a coordinate plane. Time would be labeled along your x-axis in hours. Distance in miles would be labeled along the y-axis. So this is telling you for every 1 hour, because this is 12 over 1, he bikes 12 miles. So you would go over 1 hour and up to 12 and plot a point. Over another hour and up to 12. Another 12 miles and plot a point. And if this graph was big enough and it kept going, we'd go over another hour and we would go up another 12 miles. And then because in 0 hours, he doesn't bike any miles. In 0 hours, he bikes 0 miles. So that would also be an ordered pair. So we would draw our straight linear line. So this is just telling you the unit rate is the slope of the line. This is your slope. This is telling you the cyclist can ride 12 miles per hour. Okay, we will continue more tomorrow.